Now we're going to think about something called the inverse operation. And this is really useful to us when we start to think about solving algebraic equations. But let's begin by looking at a simple balanced equation. So if I said to you 8 add 4 equals 12, we know it's balanced because it's 12 on both sides. Let's call that the left-hand side of our equation and call that the right-hand side. Now if I wrote it like this and said 8 equals 12, you can see immediately it's no longer balanced. We need to do something with this number 4 to help us. So notice what we can do. If I put it there, 8 equals 12 take away 4. 12 take away 4 is 8. Well, we know it's balanced now. And notice what's happened. On the left-hand side of our equation, the number 4 is serving as to add. When we take it onto the other side of the equation, notice what happens. It now becomes a negative. And we use a little phrase to help us remember this principle, this inverse principle. When we change the side, we change the sign, we change the operation. Let's have a look at another example. So this time, if we had 7 take away 3 equals 4, it's now balanced. 7 equals 4, it's no longer balanced, but what we can do, let's change the side. And so what do? We change the sign. So instead of -3, it now becomes +3. Is it balanced? Yes, it is. 7 equals 4 plus 3. Let's have a look at 2 more examples. So this time, if we said 8 times 4 equals 32, it's balanced, but 8 equals 32 is no longer balanced. What do? We change the side, and I can hear you telling me, we change the sign. So from multiplying to dividing, does it now balance? 8 equals, what's 32 divided by 4? The answer's 8, so yes, it's balanced. And the last one, if I said, what is 27 divided by 9 equals 3, it's now balanced. If I said 27 equals 3, clearly it no longer is. But what do? We change the side and we change the sign. Does it work now? 27 equals 3 times 9. 3 times 9 is 27. So remember that little phrase for the inverse operation. When we change the side, we change the sign. And that's it.